We're going to be talking about moving continents, or more specifically, about tectonic plates. Now, before this theory was widely accepted, it was believed that the Earth's continents pretty much stayed in exactly the same spot and that they maintained the same shape. Now, it was only in the early 1900s where a scientist by the name of Alfred Wegener, he came up with some ideas. Now, he was a polar explorer and a geophysicist, and in his travels he noticed some really interesting facets of the Earth. And he came up with the idea that what would happen if all the continents actually moved. And not only did they move, but at one point they might have been joined together. Now, to demonstrate this, he came up with 4 sets of evidence. The first of these is involved in the shape of the Earth. Now, if you have a careful look, you can see that the shape of South America here and Africa over here match up pretty closely. So this dimple here will fit into this gap here. Now, he also noticed, and it's a little bit hard to see from this map as it's flattened, that Australia actually fits into this spot here. Antarctica actually fits into the gap here with India, and that North America and Eurasia also join up quite well. He took a look at it and he said it's pretty much like a jigsaw puzzle. Put them all together and you get one giant continent. Now, his second piece of evidence is to do with fossils. Now, he looked at Triassic period fossils, and what he found was that each type of fossil actually linked up the different continents as well. So we'll have a look at Cyognathus first, and I'll mark it off as yellow. And he found that these fossils actually existed through a band here in South America, and again, like this, through Africa. He also looked at the fern, Glossopteris, and this is one of the ones which actually spanned across quite a few of the continents. And it actually exists in fossil form through here, in South America, up into Africa, through the Indian subcontinent, and then it's also found in Antarctica in a space pretty much like this, and then finally finishes off in Australia like that. And as you can see, it has a pretty clear run around and down and then up again. Now, the next one he looked at was Listosaurus. Now, Listosaurus existed through Africa, and it spread around like this, and then ended up in Antarctica like this. So together with the fern, this one made a pretty strong evidence that Antarctica and Europe and Africa were joined together. Now, the final one they looked at was mesosaurs, and these were a marine reptile, and they're actually found in fossils through here in South America, and again through Africa here. So you can see now with the 3 sets of fossils running through here, it really demonstrates the possibility that the 2 continents used to be joined together. Now, the next piece of evidence was to do with rocks. What he found was that there are certain groups of rocks which exist in South America, like so, and exactly the same rocks exist through Africa around here. Now, the only way that these rocks could be identical was if they were formed together in exactly the same spot. Again, another piece of evidence that suggests that these 2 continents were actually joined together. The last piece of evidence is to do with glaciation. Now, glaciation is where glaciers travel across the land, and more particularly he was looking at glacial scarring, which is the scratches which glaciers leave as they travel across the land. Now, what he found was that there were scars which actually were in South America through here, all through the lower part of Africa, all through here, and Madagascar, across the Indian subcontinent, all through here, the southern part of Australia, and right across the entire stretch of Antarctica. Now when he put them together and he actually looked at the way that the scars face, he came up with this image here. And as you can see, coming from Antarctica, there's glacial moving that way, through like that and that way, and then finally out this way. So again, a really strong suggestion that the glaciers and the continents were joined together in one supercontinent. Now, after he'd collated all this evidence, he came up with an image of the supercontinent, and he called it Pangaea. Now, Pangaea means one land. And as you can see, here are all the different continents. So we've got Antarctica over here, Australia and India joined to it. There's Africa and South America, and you can see that shape through there where they join together. There's North America and Eurasia, which is Europe, China and Russia. Now, there was one really big problem with all of this. He had the evidence showing that it could have happened, but he couldn't prove how it happened. There was no mechanism known at the time which actually showed how continents could move. And as a result, people wouldn't believe him. He was pretty much laughed out of the scientific community. Now, Alfred Wegener was a pretty strong person. He knew that he was right, he just needed to find the proof, and he continued to look for his evidence. Unfortunately, on one of his expeditions to Greenland, he unfortunately died, and this was in 1930. Now, only about 10-20 years later, the evidence that he was looking for actually did show up. So it's really unfortunate that he did pass away and didn't see his own theories proven. Now, this evidence actually started to build before Wegener was actually born. He, going back into the 1870s, there was cable being laid across the globe connecting all the countries in the first communications network. Now, one of the main ones through was from Europe to North America. Now, as they were laying this, they discovered that in this location here, there was a huge undersea mountain range. And, you know, it's a mountain range. Yeah, you get those up in the terrestrial areas as well, Mount Everest, the Alps, the Pyrenees. So there was no big deal about it. And it was just noted down as a mountain range. But in 1925, so 5 years before Wegener's death, they actually started doing sonar studies through the oceans, and actually found that this here mountain range not only went through where the cable went through, but it actually stretched right up to Greenland and moved its way down, right down to the bottom of the world. So it literally stretched from the top North Pole down to the bottom and the South Pole. And eventually, as they did these surveys, they discovered that not only was there one mountain range, but they actually stretched all the way around the world, forming a series of ranges and cracks which make up eventually what we know as the tectonic plate boundaries. Now, this is the end of this lesson. Next lesson we'll talk about what sonar is, and then move on to seafloor spreading and the creation of tectonic plate theory.